Alrighty, good morning, everyone. Well, for you, it's morning. As you can see, I am doing this rather late in the evening because I can't sleep. I had too much caffeine way too late. But we're going to try our best, and I'm going to try my best not to cough throughout this. I know that does not give good sound quality. So instead, we're going to just do our best and get through this. Number one, I miss you guys. Number two, if Mr. Hogan's in your room, I hope he's doing an excellent job. I just thought I'd give him a break. And number three, I can't wait to be back with you all next week. So let's kind of get through these notes as fast as possible. I know it's a half day. I don't want to keep you here forever on this. And you know what? I'm going to give you time to, try some of these on your own. And I'll be online for questions at the end of class, just like I was yesterday. But today, we're going to talk a little bit more about why I have been so hard on you guys about a couple different things. A couple things I've been hard on you about so far this year. Number one, when we've been substituting, I've been super on you guys about putting parentheses around everything you substitute. That's going to come into play today. The other thing that I have been super on you guys about is when we have been distributing two different things, we have been super careful to make sure we distribute to both of our terms. That's also going to come into play today. So, yesterday and the last couple days, depending on when your last class was, we have been talking about adding, subtracting polynomials. Super easy when we think about it in terms of combining like terms, right? It should be easy enough. And then multiplying polynomials. Now, from here, we have been mostly talking about multiplying polynomials when it comes to a polynomial times a monomial, right? Times one thing. A lot of little things times one thing. Today, we are going to get into talking about one binomial or two-part thing by another two-part thing. Now, you're like, Ms. Nielsen, you have told us already you have to finish adding stuff before you can multiply it together. It doesn't work like that. When they're in parentheses, they have to be added together. I know I've said this to you before, all right? But today, we're going to talk about how we can do it the other way around. So, if you remember, thinking back to our original rules when we were talking about distributing, A times B plus C is the same as doing A times B plus A times C. The same thing is going to apply today, except we're going to do it twice. So to multiply binomials, we distribute each term in the first binomial to each term in the other binomial. Then we're going to combine like terms. Oops, I didn't mean to draw through it. Combine like terms. We call this order of distributing FOIL, or the FOIL method, which is first we do the outer ones, inner ones last. Now, FOIL is just a method. It's a fun, catchy phrase. Well, I mean, in terms of math, catchy phrases, right? It's a good way of remembering it, but really what we need to know is that we are distributing to both terms. Distribution is really what we're doing here. I want you guys to write under here, distribute. If I could write faster, it'd be great, but I can't. Distribute, all right? So really what we are doing is we are distributing, but we're distributing twice. Distribute twice, all right? And that's what I want us to think about doing. So let's talk about it with this first example. If we are going to multiply x times this first x, and then we are going to do it x times 4. Now, x times x should be easy. That's x squared, all right? X times 4 should also be easy. Those are both positive, so we're going to make it 4x. So far, so good. Next, you have your second term in that set of parentheses. I'm going to go with green here. We have this 2, all right? I'm going to multiply 2 times the first term in this set of parentheses, all right? And so that's 2 times x. And then I'm also going to multiply 2 times the second term in those parentheses, the 4, all right? So 2 times x and 2 times 4. So 2 times x, that's going to be plus 2x, all right? And then 2 times 4, that's plus 8. Now we think about combining like terms, all right? Now, I once had let me finish this before I get into my analogies, because I think that's going to be better for us all. So x squared, no other like terms. We're just going to keep it as x squared. 4x plus 2x, easily added together. That's going to become plus 6x. 8, no other like terms, so we're just going to leave that as plus 8. What I have written in black here at the bottom that I am circling right now, that is my final answer. Oh, look at me directing. Now, one of my teachers at Hingham, when I worked in Hingham, one of my colleagues used to call this the rainbow smile method. Rainbow smile. So you have to do 2 rainbows and 2 smiles. I have always told you, every single time we've distributed, I have told you every single time that I like to draw my arrows in all the time. This is why. So that way I can kind of check off in my head that I have done every single operation that I have to. You cannot see me right now, but hopefully you can hear in my voice that I am gesturing and trying to make this the most important point of this lesson. All right? You must multiply each thing. So we're going to start with those first 2. So we are going to go with, I'm just going to make this one red. That's going to help. All right, we're going to go 2x times x on this side. That's going to be my first one. So that's going to be 2x squared, right? 2x times x is 2x squared. Then I'm going to go in and I'm going to say, okay, 2x times negative 5. Why is it negative 5? Because we keep that negative with the 5, right? Those two go together. So 2x times negative 5, that's going to be minus 10x. All right? Now, going to the second term. Have I done everything I can with that first term? Yes, I have. You can see because I've drawn 2 separate arrows, right? I've got my first one and my second one. As long as I have drawn 2 arrows from that first term to both of the terms in the second set of parentheses, I am good. I have completed those things. Now I'm going to go from 1x, 1 times x, right? That's 1x. I could just make that plus x, but we know in our heads, right, that there's a ghost of a 1 right there in front. All right? And then I'm going to make this purple. I think the yellow is kind of hard to see. 1 times negative 5. Ooh, that's Joker colors. Oops. That's going to be 1 times negative 5. That's minus 5, right? 1 times negative 5. Negative 5. All right, so back to combining like terms. I'm going to switch back to the black for our final answer. We have 2x squared, right? No other like terms. Then I have negative 10x plus 1x. That's going to be minus 9x minus 5, right? So this, circling it again, is my final answer. 2x squared minus 9x minus 5. Those answers are in standard form. They've got x's in them. They're in standard form. They are what we would call a quadratic equation. Thinking back, we've got a degree of 2, so that's quadratic, and it is a trinomial. All right, degree of 2, trinomial. I want you all to try number 1 here. Take a minute, pause the video, try number 1. I am going to assume that you have paused the video, or that Mr. Hogan has, or that someone has paused the video. That would be super helpful to me. But, assuming you have paused the video, going in, we're going to do this together. I'm going to draw in my arrows just like I did. Y times y, it's going to be y squared. I've got my rainbow in there, right? Y times 1, that's just going to be 1y, right? Now, purple, or green, I think we did first last time. 8 times y, that's going to be, oh, I forgot the y on the one. I'm sure you all were shouting at me. Plus 8y, awesome. And then 8 times 1 here. Okay, 8 times 1 here, that's going to be plus 8. All right, so adding this all together, you all should already have this written down. I'm just going to do it in purple so I don't have to switch again. Y squared plus 9y plus 8. All right, I would love it if you all could take a minute, try the odds on this page. Actually, just try the odds up until 7. All right, I'm going to give you 2 minutes here. I'm going to pause 2 minutes up until number 7. 7 and 9, I would love to go over with you guys. I will give you the answers to 3 and 5 in a moment, but 7 and 9, I want to go over with you. So, pause the video, 7 and 9. Okay, I'm going to unpause ourselves here. Now, when you did 3, you should have gotten x squared minus 4x minus 10x plus 40, which should have come out to x squared minus 14x plus 40. And then when you did 5, you should have gotten 4x squared plus 12x, because 4 times 3, right? Minus 7x minus 21, and you should have gotten 4x squared plus 5x minus 21. Hopefully those two made sense. If you need more in-depth sort of step process there, I can go through them either online at the end of class. Like I said, I'll be around for questions, or I can chat about them when we get back on Tuesday. Or if Mr. Hogan's in the room, awesome, ask Mr. Hogan. All right, let's look at these two. The reason I stopped us on these two is because now we have coefficients in front of our y values here. All right, the other thing is they've switched from using x's to using y's, or like here they used y's. It doesn't matter, just like it doesn't matter all the other times. So we've got 3y times 3y. That's going to be 9y squared. All right. And then we have 3y times 2. So that's plus 6y. All right. And then we're going to do 1 times 3y. That's the wrong color, Ms. Nielsen. 1 times 3y. I'm just trying to stay consistent so that way you guys can follow along. 1 times 3y is 3y, right? And then 1 times 2 is going to be plus 2. Okay? So, combining these all back together and switching back to my black, 9y squared plus 9y plus 2. Seem about right to everybody? We're all good? All right, try number 9. Do it on your own. I'll give you just a minute here. Okay, now that I've given you all a minute to do number 9, I am going to go over it briefly, and then I'm kind of going to send you guys off on your own to do some work for the rest of class, and it should be a pretty simple rest of class. So we're doing 8h times 3h, that's going to be 24h squared. Then we're going to do 8h times negative 1, so that's minus 8h. Then I have negative 3 times 3h, that's going to be minus 9h. And then I have negative 3 times negative 1, which is going to be plus 3. All right. Now, we should, at the end here, have 24h squared minus 17h plus 3. Hopefully that all went according to plan and everybody sort of got what we were going with there. Now, if everyone could flip to the next page, I just want to talk about 2 more problems here before we talk about binomials times trinomials. We're going to ignore the geometric application part at the bottom of this page. Completely don't need it. We're not even going to talk about it, okay? Now, we want to look specifically at 15 and 17 here, all right? These are super important for me to talk about with you guys, all right? 16 and 18 also fall into this category. Oh, wait, sorry. I do also want to touch base real quick on 11. Sorry, I am a little scatterbrained. We're going to blame it on the COVID, all right? So let's talk real quick about 11, and then we'll duck down to 15 and 17. 11 works just like the others. We've just tossed an extra coefficient in there, all right? So, oops, wrong color. There we go. 5x times x, we're still going to get 5x squared, all right? 5x times negative y, though, just remember, like we did when we were multiplying other variables in previous units, we're just going to make it negative 5xy, all right? It's going to be simple enough. And we got 4yx, all right? So 4y times x. If you want to say 4yx in your head, that's fine. But remember, we've been talking a lot about standard form, so we need to actually make that into alphabetical order. So we're making it plus 4xy. Now it looks like they're like terms in our head, all right? And then we're doing 4y times negative y, which is actually going to get us negative 4y squared. And you're like, Ms. Nielsen, it's squared. Why isn't it positive? Well, the negative only shows up on one side. All right, so if the negative had been in both locations, then it would be a positive. But because it's only a negative on the one side, we only have one negative, and therefore we're minusing 4y squared. We're subtracting 4y squared, all right? Now, 5x squared, I don't see any other x squareds on here, so we're just going to leave that as is. We're going to copy that down exactly, all right? Minus 5xy plus 4xy, that's going to be minus xy, all right? And then we're also going to subtract 4y squared. Now, you are looking at this and you're like, Ms. Nielsen, the exponents are in greatest to least order. Look, you've got a y squared stuck at the end. Yes, I do, but you have to remember we are in standard form here where we go in alphabetical order. Alphabetical order is more important to us than numerical exponent order. So I honestly think about it in terms of like my y's are at the end in these parentheses here, right? This is y's at the end and that y's at the end, so my y's are going to be at the end here. That's how it makes sense in my brain. I was going to skip 13, but then I noticed that 13 actually has a fun little trick to it that I actually really enjoy. All right. So we're going to touch on it briefly. You all know how to do all of our little rainbows and smiles at this point. 2r times 2r, that's 4r squared. We've got 2r times negative s, that's minus 2rs. We've got s times 2r, that's plus 2rs. And then s times negative s, that is minus s squared. This is what we call a difference of squares, all right? Now, we call it that, remember, difference. Oh, my AirPod just died, but that's okay. Remember, difference means subtract, and we're subtracting squares. And now, some of you may have already noticed what's going to happen, but this middle part is actually going to cancel out. Negative 2rs plus 2rs becomes 0. So now I have 4r squared minus s squared, hence the name difference of squares, right? I'm doing an r squared minus an s squared. Anyways, that was my only little fun point. I'm going to speed through, well, I'm not going to speed through 15 and 17, but I'm going to go kind of fast. You guys are at this point now where you are already kind of getting the vibes, I think. So we are just going to keep an eye on what I'm doing. The most important thing that I need you to note here, for 15 and 17, everyone's eyes up here on the board. Everybody, eyes up front on the board. You too. I see you. Hey, eyes up here. Eyes up here. I can see you. You know that? I can see you right now. All right. Eyes up here. Do not, under any circumstances, distribute your exponents. Do not distribute your exponents. You distribute your exponents, I take away all candy privileges. No one gets any more candy. All right? Do not distribute your exponents. All right? You distribute your exponents, I get sad. When I say do not distribute your exponents, I'm going to write in red what you should not do. Do not. No one do this. No one write this down. What I do not want to come in on Tuesday and see is people doing this. That is not the answer. No. No, no, no. Do not do that. Do not do this. This will make me sad. No, not your answer. If you do that, I will be so sad because you are forgetting the number one rule of exponents, which is we are taking this thing and multiplying it this number of times. So, what I mean by that is we are taking x plus 4 and we are replicating it. We are cloning it. That's what that exponent does, is we are multiplying it 1, 2. That is what that does. That is the correct answer. Everybody should take a peek at this. I'm changing its color to black so that way everybody knows to write it down. I'm going to change that back to green. That's fine. All right. Write that down. X plus 4 times x plus 4. That is what I am looking for here. I am not looking for you to take that exponent and go x squared plus 4 squared. This is wrong. You should be doing this. This is the correct response. Anytime you see those parentheses, duplicate it. Duplicate it, duplicate it, duplicate it. Do not, under any circumstances, distribute your exponents. Yes, I know, I said circumstances weird. Do not distribute your exponents. Do what I have here in black. That is your goal. Because now, from here, you go x times x, x times 4, 4 times x, 4 times 4. All right? That gets you to x squared plus 4x plus 4x plus 16. That is x squared plus 8x plus 16. If you have learned nothing else from me in this math class, this is the main thing I want you to walk away with. Number one most important thing that I want you to walk away with from math class this year is that x plus 4 raised to the second power is not x squared plus 4 squared. It is x plus 4 times x plus 4. It is the most important thing. So, this should be rewritten as 2m minus 5 times 2m minus 5. And if you're like, Ms. Nielsen, I can do that in my head. I don't care. I want you to write it down. Writing it down is the most important part here, okay? Thank you. 2m times 2m is going to be 4m squared. From there, we're going to do 2m times negative 5. That's negative 10m. Negative 5 times 2m. I did that in the wrong color. Negative 5 times 2m. That's going to be negative 10m squared. Negative 5 times negative 5. That is going to be plus 25. All right? So, in the end, your final answer for this one should be 4m squared minus 20m plus 25. That is your final answer. I'm going to do one of these binomial times the trinomial problems, and then I'm just going to call it quits so you guys can start your homework. All right, I'll do one of these out. The rules are exactly the same. I do want to see you drawing out your arrows. In fact, it's even more important here to draw out your arrows in some ways because there's more items. So you've got x times x squared, that's x cubed, right? Then you're going to do x times 3x. That's going to be plus 3x squared, all right? From there, I'm going to add in another color so we don't get confused by all of everything that's happening in here. We'll go with this blue. We'll do x times negative 6, that's minus 6x, all right? The difference here with binomial times trinomial is you just have to do the binomial 3 times. Now we're going to do plus 4x squared plus 12x, and then our last one, I'm going to go back to that orangey yellow color, 4 times negative 6 minus 24. I'm going to go over this part more in depth on Tuesday when I'm back, all right? But for now, we just have to combine like terms and call ourselves done. So x cubed, there's no other x cubes. We have a plus 3x squared and a plus 4x squared. That's going to give us plus 7x squared. From there, we have a minus 6x plus 12x. That's going to be plus 6x. All right, and then minus 24. Tack it on the end. Ooh, I'll give that a different minus 24. There we go. That's different enough from the other two, I think. All right, minus 24, we tack it on the end. That's your final answer. If you are still confused about the binomial versus times trinomial part, that's fine. We're going to go over this more in depth on Tuesday. But as far as the rest of it goes, most important thing you learned today, do not distribute your exponents, all right? Just don't do it. It'll make me sad. I'll cry. No one wants me to cry. Well, I'm sure some of you do, but just don't tell me that you want me to cry, because that would make me sad, all right? Thank you so much. I will see you guys all on Tuesday. I'll be on Classroom at the end of class today. If you have any questions, feel free to shoot me a message there, all right? Goodbye.